Hey y'all, we're on to our next video. So this is the third one. This is on solving by taking the square root. Please don't forget to take notes as you go, whether it be on your own paper or you can use the guided notes that we are using as well. It doesn't really matter as long as you come up with all the examples. What we want to know about this one is by solving by taking the square root only occurs for one type of problem. These are the kinds of problems where there's no b value. So you know you have ax squared plus bx plus c like this. When this value in the middle is missing, so essentially all we have is the ax squared and the plus c, this is the method that where you can use. It's an option for you to use. Sometimes you can still do factoring, but that's only if these two things are perfect squares and there's a minus c in the back instead. So just keep that in mind. So just to kind of relate it to what I was just talking about, we've worked with these kinds of problems in the past, the 25x squared minus 36. It's a difference of two squares because you got a perfect square in the front and you got a perfect square in the back. So we know we're solving because it says equal to 0. And so what we can do is factor it in the quick way that we've learned. The square root of 25x squared is 5x, and then the 36 is 6. So we have 5x plus 6 and 5x minus 6. From our previous lesson, we then took the 5x plus 6, set that equal to 0, the 5x minus 6, set that equal to 0, and then we started solving. So I subtract 6, divide by 5, or add 6 and divide by 5. So what I end up with is two answers that are similar. One is a negative 6/5 and the other one is a positive 6/5. So our answer here is just negative 6/5 comma 6/5 as a solution set, or you can write it out as the x equals x equals. So with the taking the square root method, we're going to be doing it a little bit differently and might be a little bit faster for you. So let's take a look at that same problem. Instead of factoring, what we're going to do is solve for x as if it didn't say x squared. So if I gave you this problem and it just said 25x minus 36 equals 0 and I said solve for x, the first thing you do is move the 36 over. So this is different from factoring and from graphing because we needed to say equals 0. This case here, we're actually solving for x without doing any of those things. So we would then divide by the 25 and I get x squared equals 36 over 25. So with these, because of the x squared, the opposite of squaring something is taking the square root. So we're going to take the square root of both sides. And on the left side, the square root of x squared is just x. On the right, the square root of those two numbers are 6 and 5. Now, we saw this problem previously, though. We did it by factoring, and there were two answers. There was a positive one, and there was a negative one. So when we write down the positive answer, we also have to write down the negative one. Okay, so there's always two answers. The answer here, you can write it as a combined version of this as well, like this here and on the right, where it says plus or minus 6/5, or you can write them separately out like this. So x is positive 6/5, and x is negative 6/5, or combine it together. Let's do another problem. We'll just do a couple of examples from here on out. So again, our goal here is to isolate the x squared. So with the x squared, we have the 6. So we're going to divide both sides by 6. On the left, we're left with x squared. On the right, we get 81. So this is a nice perfect square. And here I'll kind of go into details to why we do both, but we saw it from the factoring that it had to have both. So if I take the square root and I said, what's the square root of 81? With solving, there's technically two answers. You would probably normally just give me the positive 9 as the answer, but we have to have positive and the negative. So the question for you is, why does that happen? Well, if we were to square out positive 9, 9 times 9 is 81. But you also have to remember, we're looking for values that we're going to plug in that make the solution true. And so in this one, we can also plug negative 9 in because negative 9 times negative 9 is 81. Sorry, I want to put the lights back on. So yes, we always have to have the positive and the negative. So you can write it out as plus or minus 9, or you can say x equals 9 and x is equal to positive 9. Okay, there should be an equals negative 9 there. All right, let's just keep on doing some more examples because sometimes they're not going to be perfect squares. So here's the next case with x squared plus 9 equals 59. We're going to isolate the x by subtracting 9 from both sides. That gives us x squared is equal to 50, and then we're going to take the square root of that. Now, when you take the square root of 50, you do get a decimal. So for right now, for this lesson, all I want you to do is put plus or minus the square root of 50. When we get back in class, we're going to talk about how do we simplify that down further. Okay, because there's perfect squares in there. We're going to simplify some radicals, and it'll be a good time. So subtract 9 square root plus or minus the square root of 50 because when you take the square root of 50, it's a decimal. All right, a couple more. Keep on going. So same process, isolating the k here instead of the x, no idea. So first thing we'll do is add 1 to both sides. That gives us 10k squared equals 90. Then divide by 10, just like before. and you get k squared equals 9, so we're going to take the square root of 9. And don't forget, we have two answers. We got 3 or negative 3, not just 3. That's the biggest thing that most students forget, is to do both. All right, nope, second to last one. So again, solve for x here. I'm going to subtract 6 from both sides, getting x squared equals 728. Divide both sides by 8. You get x squared equals 91. This is not a perfect square. When we do our division, or sorry, square rooting, the opposite of x squared is square rooting, we get a decimal. So for right now, we're going to put 91 or negative square root of 91. But we're not going to put, or you can put it together as plus or minus the square root of 91. Both answers are correct. We will talk about how to simplify this later, but it does correspond to a decimal. It's about 7 point something. Nope. 9 point something, like 9 point something. I don't remember what it was. Okay. Last but not least here, this I believe is our final example to emphasize what happens. So in all those cases there, we had two solutions. Let's see what happens here. So I'm going to add 5 to both sides, and I got negative 149 there. When I add 5 to it, I get negative 144. So 8k squared is equal to negative 144. Divide both sides by 8, and I get k squared is equal to negative 18. So when I take the square root on both sides here, what I want you to do is, in a moment, is to take the square root of negative 18 in a calculator of some kind. I'm going to pause for just a moment. Hopefully you actually went through and tried to take the square root of negative 18 in a calculator, and you paused it. If you haven't paused it, pause it now to do that. And then take a look at what it says. When you take the square root of a negative number, it should come up with something that says error or something like that. I can show it to you. My calculators here. So like if I took the square root of negative 18, so if you look at the top, it might be saying it backwards, okay? But it's error, non-real answer, quit or go to. So when you get an error like that, that means it's imaginary. Okay, so we talked a little bit about imaginary in class and you get that. So just keep that in mind. Okay, so that's the idea. Remember, we only do this when there's no B value. If we have no C value, we can take out the GCF. We have to make sure we have a positive and a negative root. We can't just have one. And then you can't take the square root of a negative number. Those guys are imaginary. So in this class, we're just going to stick with imaginary. And then anything after this class, like in Algebra 2, you'll take that farther. All right. Hopefully you've taken notes. If not, go back. Please make sure you take them, and I'll see you in class.